طلبة وطالبات الثانوية العامة القسم العلمي رياضيات لغات، أهلا بيكم في حلقة جديدة من حلقات برنامجنا برنامج ديناميكس. النهاردة إن شاء الله هنستعرض موضوع من موضوعاتنا المهمة وهو موضوع The Power. الباور درس مهم جدا بيجيلي عليه أسئلة كتير في الامتحان، والباور ده بيربط لي ما بين أول درس خدناه وآخر درس خدناه، فمهم جدا أكون بعرف أتعامل مع كل حالة من حالات الباور على مهلي وبتركيز ودقة. Dear students of grade 3 secondary, welcome to our methods program. Today we have dynamics. Our lesson today is power. What is the power? Definition of the power. The power is the time rate of doing work, or the power is the work done in unit time. Power equal dW dt, the rate of change of work with respect to the time t. The power equal derivative of the work. Work equal F dot S with respect to time t. When F is a constant, then the power equal F ds dt, which equals F times V. Then the power equals force times velocity. Now, unit of measure of power. The power equals dW dt, or the power equals Fv. We can use Newton for force and meter per second for velocity, or dyne for force and centimeter per second for velocity. Then Newton meter per second equals 10 power 7 dyne centimeter per second. And horse equal 75 kilogram weight meter per second. Horse equal 75 times 980, or 735 Newton meter per second, or joule per second, or horse equal 735 watt. Now let's start with the first example. A person of mass 50 kilogram ascend the stairs of a tower of height 441 meter in time of magnitude 15 minutes. Calculate the average power in watt unit. This man of mass 50 kilogram ascend the stairs of a tower. Then the force acting on the man, mg, its weight, which equals 50 kilogram times 9.8 meter per second squared equals 490 Newton. Now, the person's average velocity equals distance over time. The distance equals 441 meter, and the time equals 15 minutes. 15 minutes times 60, then the time now in second. 441 over 15 times 60 equals 0.49 meter per second. Now, the average power equals force times velocity, F times V. The force 490 Newton and the velocity 0.49 meter per second. Then the average power equals 240.1 Newton times meter per second, or joule per second, which equals 240.1 watt. Note: when the body moves with a uniform velocity or uniform motion, then the power is constant and is equal to the product of the force and the uniform velocity. Let's have an example on this rule. A car of mass 2 tons moves on a horizontal road with a uniform velocity. Uniform velocity of magnitude 108 km per hour against resistance equivalent to 150 kilogram weight per each ton of the mass. Calculate the power of its engine in horse. The body moves with a uniform velocity. Then the acceleration equals 0. According to the Newton first law, then the force equals the resistance. F equals R equals the resistance 150 kilogram per each ton. Then F equals R equal 150 times 2 equal 300 kilogram weight. 300 kilogram weight is the resistance of the body or total resistance of the body. Then F equals 300 kilogram weight. What is the car's velocity? 108 kilometer per hour. 108 kilometer per hour times 5 over 18 equals 30 meter per second. Now power equal F times V. The velocity in meter per second and the force in kilogram weight, then power equal 300 kilogram weight times 30 meter per second, which equals 9,000 kilogram weight meter per second. Now the required is the power of its engine in horse. Then 9,000 divided 75 equals 120 horse. Then the power of the engine equals 120 horse. Note, when the body moves with maximum velocity, then the power is a maximum power, and this is called the maximum power. Let's have an example on this rule. A car of mass 9 tons ascends a slope inclined at an angle of sine 1 over 125 to the horizontal with maximum velocity of magnitude 45 km per hour against resistance equivalent to 200 kilogram weight per each ton of the mass. Calculate the power of its engine in horse. Now we can draw an inclined plane, makes an angle of sine 1 over 125 to the horizontal, and a car of mass 9 tons moves on the plane, ascend a slope inclined plane. Then the engine force F in the direction of motion and the resistance in the opposite direction of motion. The resistance always parallel to the plane of motion and in the opposite direction of motion. And the component of the weight mg sine theta in the direction of the line of the greatest slope downward the plane. The motion is upward the plane, then the equation of motion is F equals R plus mg sine theta. Remember that when the velocity is maximum, then the acceleration equals 0. Then F equals R plus mg sine theta according to the Newton first law. Then F equals 200 times 9 times 9.8. 200 is the resistance per each ton in kilogram weight times 9. Then 200 times 9 is the total resistance in kilogram weight times 9.8. Then the resistance now in Newton units plus mg sine theta. M 9 ton times 1000. Then 9 times 1000 in kilogram times M times G 9.8 meter per second square times 1 over 25. Then the velocity equals, then the force equals 2520 kilogram weight. What is the maximum velocity of the car when ascend the slope? Equal 45 kilometer per hour. 45 kilometer per hour times 5 over 18 equals 25 over 2 meter per second. Then the maximum power of the car equals F times V equals 2520 times 25 over 2 divided 75 equals 420 horse. Note that the force in kilogram weight and the velocity in meter per second, then kilogram weight meter per second divided 75 equal horse. Then the maximum power of the engine equals 420 horse. Dear students, note that if the rate of doing work is uniform or constant, then the power equals work over time equals force times distance over time. Let's have an example on this rule. A worker whose job is to load boxes each of mass 330 kilogram on a track. If the height of the track is 0.9 meter, calculate the number of boxes which the worker can load in time of magnitude 1 minute if his average power is equal to 0.6 horse. Now, the power equals total work over time. Then, power equal total work is the number of boxes times work need to load a box over time. What is the number of boxes needed to be loaded in minute or in 1 minute? Equals power times time over the work to 1 box equals power is 0.6 horse times 735 over 30 times 9.8 times 0.9. In 1 second, the number of boxes needed to be loaded in a second equal 0.6 times 735 times 1 second. But we have 60 seconds because 1 minute equals 60 seconds. But now, number of boxes needed to be loaded in a minute equal 0.6 times 735 times 1 minute or 60 seconds over 30 times 9.8 times 0.9. Then, the number of boxes needed to be loaded in 1 minute equals 100 boxes. Another example. A train of mass 200 ton ascends a slope whose inclination to the horizontal is an angle of sine 1 over 20 with a uniform velocity. Uniform velocity of magnitude 27 km per hour against resistance to the motion parallel to the direction of the line of the greatest slope of the plane at a rate of 18 kilogram weight per each ton of the mass. What is the power of the engine in horse? If the train descends on the same slope with the same velocity, what is the power of the engine? In this case, supposing the resistance are constant in both cases. Now, first case, when the train ascends the slope, the direction of motion is upward, parallel to the plane of motion upward, then the engine force in this case upward and the resistance in the opposite direction of motion or downward. Motion resistance equals 200 times 18 equal 3,600 kilogram weight. 200 ton times 18 equals 3,600 kilogram weight, which is the total resistance. The component of the train weight in the direction of the plane equals mg sine theta. 200 times 1,000, the mass now in kilogram, times sine theta 1 over 200 in kilogram weight equals 1,000. Then the weight sine theta equals 1,000 kilogram weight. The train ascends with a uniform velocity. then acceleration equals 0 according to Newton's first law. Then the force of the engine F equals the resistance plus component of weight. Then the force equal 3,600 plus 1,000 equals 4,600 kilogram weight. Now power equal F1V. Power F1 force of the engine when the train ascends the inclined plane. Power equal F, which equal 4,600 kilogram weight, times the velocity of the body, which equal 27 times 5 over 18. Then the power now in kilogram weight times meter per second. 4,600 times 27 times 5 over 18 times 1 over 75. Then the power now in horse. By using your calculator, then the power equal 460 horse. The second case, when the train descends the slope, then the train descends with a uniform velocity. Then the acceleration equals 0, and according to Newton's first law, the force of the engine equal component of weight equals resistance. The force plus mg sine theta equal the resistance. Then force of the engine plus 1,000 equal 3,600. Then the force equal 3,600 minus 1,000 equals 2,600 kilogram weight. Power equal F2V, where F2 is the force of the engine when the train descends the slope. V is the velocity, and the velocity doesn't change. Then power equals FV. F equals 2,600 kilogram weight times the velocity, which equals 27 kilometer per hour times 5 over 18 times 1 over 75. Then the power of the engine of the car equals 260 horse. And we know that the power when the train ascends the inclined plane equal 460 horse. When he descends the plane, the power equals 260 horse. The power is decreasing when the train descends the inclined plane. Another example. A particle of mass 1 kilogram moves under the action of a force F equal, vector F equal 3I plus 4J, such that its displacement vector S is given as a function of time by the relation S equals 3t power 2I plus 6tj, where I and j are two perpendicular unit vectors. Find the work done by this force. Then find the power when t equals 2 seconds. If F is measured in Newton, S measured in meter, and t in second. Dear students, we know that the work W equals vector F dot vector S. Vector F, which equals 3 and 4, dot vector S, which equals 3t power 2 and 6t. Then the work equal 3 times 3t power 2 equals 9t power 2, 9t power 2 plus 4 times 6t, which equals 24t. Then the work equals 9t power 2 plus 24t. Now we know that the power equals the derivative of work with respect to time, dw dt. Then power equals the derivative of 9t power 2 equals 18t plus derivative of 24t equals 24. Then the power equals 18t plus 24. Now, what is the power when t equals 2 seconds? When t t equals 2 seconds, power equals 18 times 2 plus 24, power equal 36 plus 24, then power equals 60 joule per second. Dear students, note that since the power is dw dt, then the work equals integration power dt from T1 to T2. A particle of mass 1 kilogram moves under the action of a force F vector equal 3I plus 4J, such that its displacement vector S is given as a function of time by the relation vector S equal 3t power 2I plus 6tj, where I and j are two perpendicular unit vectors. Find the work done by the force, then find the power when t equals 2 seconds. If F is measured in Newton, S in meter, and t in second. Dear students, we know that the work W equals vector F dot vector S. Work equals vector F, which is 3 and 4, dot vector S, which equals 3t power 2 and 6t. Then the work equals 9t power 2 plus 24t. Now the power is the derivative of the work with respect to time, dw dt. Then power equals the derivative of 9t power 2 is 18t, and the derivative of 24t is 24. When t equal 2 seconds, then power equals 18 times 2 plus 24. Then the power equal 36 plus 24, which equals 60 joule per second. Dear students, we know that the power W equals integration of power dt from T1 to T2. Example: if the power of an engine at any time measured in second is equal to 9t power 2 plus 4t, find the work done by the engine during the first 3 minutes, then find the work done during the 4th second. Now, the power equals dw dt, the derivative of the work with respect to time. Then, the work equals integration power dt from T1 to T2. The work done during the first 3 seconds, or from 0, t equals 0, to t equals 3 is integration 9t power 2 plus 4t dt from 0 to 3. Then the work equals 3t power 3 plus 2t power 2 from 0 to 3. We can calculate the integration by the calculator or by substitution. Then the work done equals 99 work unit. Now, the work done during the 4th second. The 4th second mean from t equals 3 to t equals 4, because the 4th second beginning when t equals 3 and till t equals 4. The integration of 9t power 2 plus 4t equals 3t power 3 plus 2t power 2 from 3 to 4. We can calculate the work by the calculator. Then the work equals 125 work units. Another example: find the time taken by a car of mass 1,200 kilogram to reach the velocity 126 km per hour from rest if the power of the engine is constant and equal to 125 horses. Now, the work equal integration power dt from T1 to T2. Work equal integration. The power 125 horse times 735 Then the power now in what? The integration with respect to t from 0 to t. Work equals 125 times 735 t. The work equals change in kinetic energy. Then work equals t minus t node, or t minus t node equals work. Half m v squared minus v node squared equals 125 times 735 t. The mass of the car equals 1200 gram. Then half times 1200 times the velocity 126 times 5 over 18 all power 2. 126 times 5 over 18 because the velocity now in meter per second, minus the initial velocity which equals 0 because the car moves from rest, equals the work which equals 125 times 735 t. Then the time t equals 735 times 1000 over 125 times 735, which equals 8 seconds. Dear students, note that the power is determined at any instant, while the work is determined between two instants or during a given displacement. Number 2, when the body moves with a variable motion, then the power is variable, and at a given instant, the power is equal to the product of the force and the velocity at this instant. Number 3, when the body moves with its maximum velocity, then the power is maximum power, and this is called the maximum power of the engine. Number 4, if the rate of doing work is constant, then the average power equals work over time. This note is very important to solve the examples which makes a relation between the work and the power. Note that the average power equal work over time. Power equal dw dt, the derivative of the work with respect to time. Then now we have two meaning of the work. The average power equal work over time, and the power equals dw dt, or the rate of change of work with respect to the time. بكده أعزائي نكون استعرضنا مع بعض آخر موضوع من موضوعات منهجنا، وهو موضوع الباور، وعرفنا ان الباور بيربط ما بين دروس كتير قوي سبق ودرسناها. يعني عرفنا ان الباور نقدر نستخدم فيه الديريفيتيف، نقدر نستخدم فيه الانتجريشن. كمان الباور ربط لي ما بين الديسبيسمنت والبوزيشن فيكتور، ربط لي ما بين الورك وما بين الكينيتيك انرجي، ربط لي ما بين الاس والفي والاكسلريشن. عرفنا امتى نستخدم الباور لو كنا شغالين بماكسيمم فيلوسيتي او يونيفورم فيلوسيتي. ممكن يكون الباور نفسه فاريبل وممكن يكون كونستنت. الفورس قد تكون كونستنت او قد تكون فاريبل. في كل الحالات ديت لازم اكون بتعامل مع الموقف وانا واخد بالي ومركز. هل الفورس اللي عندي كونستنت يعني ما فيهاش تايم، ما فيهاش اكس، ما فيهاش في، ولا فيها؟ لو كان فيها يبقى انا هشتغل بالانتجريشن زي ما شفنا قبل كده. كمان اخد بالي لو عايز الافريج باور ولا عايز الباور. خدنا بالنا ان الورك ايكوال انتجريشن للباور. كمان عرفنا ان الباور نقدر نحسبه عن طريق اليونتس بتاعته، عن طريق الهورس او عن طريق الوات. وعرفنا ان الوات هو جول بير سكند او نيوتن متر بير سكند. لازم اعرف اكون مربط ما بين اليونتس دي كويس عشان وانا بشتغل اكون عارف ايه اليونتس اللي عندي وايه اليونتس المطلوبه مني. عشان دايما الاسئله الام سي كيو بتبقى محتاجه اكون عارف اليونتس اللي هو عايزها ايه، لانه ممكن يطلب مني يونتس غير اليونتس المستخدمه في المعلومات اللي ادهاني في السؤال. Dear students, now we come to the end of our program today, and till we meet again, it's goodbye.